Hi everyone and welcome back to my channel Economist. So today what we will do, we will start with the tests of heteroscedasticity. So if you are someone who is following my econometrics playlist from some time, you will know that I was talking about heteroscedasticity. I have covered what is the concept of heteroscedasticity, what is the consequences. Also, I have gone into why WLAC is the best estimator or the blue estimator when heteroscedasticity is present in your regression model, right? Now, in this video, I'll be talking about what are the formal tests that you could use if heteroscedasticity is present in your model in order to detect heteroscedasticity in your model. Specifically, in econometrics, you have three types of test, formal test that you could use in order to detect heteroscedasticity, and here I have listed all of them. The first is the Spearman's rank correlation test that we will be talking of in this particular video. Then the second test and the most useful test is the Goldfield quant test that we will be talking in the next video. And then you have something called the LM test or the White's test. LM test is also called the White's test. So these three methods will have three separate videos. In this particular video, I'll be showing you what is Spearman's rank correlation test and how using this particular test, you can detect heteroscedasticity in your model. I will be giving you a numerical example also on this. In the subsequent videos, I'll be going into Goldfield quant test and LM test and do the same, right? So today, let us start with the process of Spearman's rank correlation. This is the topic for today, right? So what is Spearman rank correlation test? So if you know the formula, let me write. We know the Spearman's rank correlation coefficient is defined as how do you define the formula? Let us see. The formula is this. RS. This is the rank correlation according to Spearman. R suffix X. S, which is 1 minus 6 summation I from 1 to n di square upon n into n square minus 1. Right? This is the formula. 1 minus 6 summation di square upon n into n square minus 1. Or you can give a bracket. This. This is the formula for Spearman's rank correlation coefficient. Now, what is this di here? Where this di represents the difference. Di represents the difference in the rank assigned to two different individuals. And n is the total number of observations. Total number of observations, right? So this is the formula. According to Spearman, the rank correlation coefficient can be found out using this particular formula, where di is the difference in the rank. Now, when I will give you the example, I'll formally show you how to find out this difference in the rank assigned to two different individuals, and n will be the total number of observations. Now, let us see how we can implement this formula in our particular regression model, our two variable linear regression model. Suppose our model is this, the usual model that we work with, which is this, right? This is our usual two variable regression model. Now, what would be step one? Let us start with step one. In step one, what you have to do, you have to fit this regression model. Fit the regression model and obtain the residual error. and obtain the residual error, which is nothing but epsilon I cap, basically. Residual error or epsilon. I hope by this time you know what is the difference between error and residual. A residual is the estimated portion of error, nothing else. When you fit the model, you will get this residual estimated value of this residual, that is known as the residual error. So this is the first step. When you have this two variable regression model, firstly, what you have to do, you have to fit this regression model. You can use softwares for that, or you can do it manually. Manually, the process becomes very difficult. We usually rely on softwares. So we have to fit the regression model and then obtain the residual error from. Now, what is step 2? In step 2, you have to ignore the sign of the residuals, that you have got in the previous step. That is, you have to take the mod values of these residuals. You have to take the mod values of residuals and then rank both the residuals and the independent variable xi according to ascending or descending order. This is step 2. I know that this looks difficult right now, but when I'll give you the example, it will be absolutely clear. I'll show you each step using a data set, right? So step 1 says fit the regression model and obtain this residual. This residual estimated error is called residual. Find out these residual values. And then in the next step, ignore the sign of the residual. Residual can be both positive or negative. Second step says ignore the sign of this residual. So find out the mod value of that and then rank not only this absolute value of residuals, but also the independent variables according to either ascending order or descending order. We usually consider ascending order. So in our example, we will usually arrange it into the ascending order. And then, okay, ascending order. And then what do you have to do? Compute the rank correlation. Rank correlation, when I say rank correlation, I mean the Spearman's rank correlation. And the formula is this basically, which I have shown you previously. This is the formula. After you have the ranking of the absolute value of error and absolute x values, independent values, you can compute the difference, right? This di can be computed, and once you have di, n is already given to you, you can simply compute this Spearman's rank correlation. So this will be step 2, right? Now let us talk about step 3. In step 3, what you have? You will assume that the population coefficient population rank correlation coefficient, basically. Population rank, here whenever I say correlation coefficient, it means the rank correlation coefficient. Assuming the population rank correlation coefficient, suppose I call it rho s is 0. If you assume this to be 0 and you assume your sample size to be greater or equals to 5, so you have sufficiently large number of quantities. There is sufficiently large quantities, then the significance of a sample which is RS can be tested by the T statistic. As follows. What will be the T statistic value? T statistic value will be simply RS, that is the rank correlation that you compute previously. Then you have this thing, and then you have root over of 1 minus RS whole square. And this will follow under H naught, it will follow degrees of freedom. Okay. It will follow a T distribution, obviously. T distribution with the degrees of freedom will be N minus. So this will be the simple test statistic, right? Now the only thing left for us is to define the null and alternative hypothesis. What will be the hypothesis? What will be our hypothesis? Hypothesis will be H naught. H naught will assume homoscedasticity. H naught will assume homoscedasticity and the alternative hypothesis will assume heteroscedasticity. Right? This is what we will assume. And now the decision formula or the decision rule, it simply says if the T computed value is greater than the T critical value, the computed value is greater than T critical value, then we have to reject H naught. Then we will simply reject H naught against H1. Or if T computed is less than the T critical value, if this is less than T critical value, then what we will do? We will fail to reject H naught. Right? So this is the entire process of applying the Spearman's rank correlation coefficient and detecting heteroscedasticity. So we started with a simple formula. This is the formula for rank correlation coefficient. I have, given you the terms, what is DI, what is N. Now what do you have? You have a two variable regression model. The first step is to estimate or to fit the regression model and find out the residuals. Second step is to take into account the absolute value of the residuals and rank this residual as well as these independent terms in ascending or descending order, and then compute the rank correlation respectively. And step 3 says you have to find the test statistic. Here test statistic will again follow T distribution with N minus 2 degrees of freedom. Define the proper hypothesis where H naught will assume that homoscedasticity is present. H1 will assume that heteroscedasticity is present. And then the decision rule is as follows. If T computed is greater than T critical, we will reject H naught and we will say yes, heteroscedasticity is present in our model. And if the opposite happens, we fail to reject H naught and we will say that homoscedasticity is present in our model. As simple as that. Now I have given you one numerical example. Let us move to the numerical example and see what we can do with this. See this example here. Here this example says, suppose you have a two variable regression model where X is the independent variable as usual. And in the data, suppose this is the data set that is given to you. You have the X values and you have the residual values. Suppose this is residual basically, E cap, right? E cap is the residual. So how many X values are there? 1, 2, 3, 4, 5, 6, 7. So here you have 7 data points, any 7 here, and the corresponding residuals are given to you. So they have already fitted the regression model, and from that you have got these residuals. Now, what is the first step? First step, as I have told you, compute the absolute value of the residue. This will be the first step. So what will be the absolute value? Just take the mod of these values. So the first value will be 0.8. So only consider the positive values. 1.5, this is 2.3, this is 2, this is 3.2, this is 3.8, and this will be 4.5, right? This is the absolute value. Now you have to compute the ranks, right? Suppose, how do you compute the rank of X? Rank of the independent values X. So you have to simply, arrange this data into ascending order. Ascending means from smallest value, you are going to the highest value. Now, which one of the following is the smallest value? So if you look at this data, 3 is the smallest value. If you look at the data, it is already arranged in the ascending order. So 7 is greater than 3, 10 is greater than 7, 14 greater than 10, 18 greater than 14. In this way, it is already arranged in the ascending way. So what we can do, how do you write the rank? Rank of this particular value will be simply 1. This is the smallest value. We are arranging in the ascending order, which means that we are going from smallest value to the highest value. So 3 is the smallest value here and 27 is the highest value here. So what is the rank of 3? The rank of 3 is simply 1. What is the rank of 7? Rank of 7 is simply 2. In the ascending order, rank of 7 is 2. In the ascending order, rank of 10 is 3. Similarly, this is 4, this is 5, this is 6, this is 7. This is simple. Now, also you have to compute the rank of these residuals, right? This particular thing. Again, in the ascending order, what is the smallest value? See this row, see this column basically. This is the smallest value. So rank of this is 1. What is the second smallest value? This is the second smallest value. This is 2. What is the third smallest value? This is the third smallest value. This is 3. Fourth is this. This is 4. Now this is 5. This will be 6. And this will be 7. Right? I hope you got the process how to rank this particular thing. Now let us move to the next step. Here what we will do, we will compute the Spearman's rank correlation coefficient. So for that, what you have to do, you have to compute DI. What is DI? DI is simply rank of X minus rank of the residual, right? This is basically DI. If you see, first is 1 minus 1, which is simply 0. Second is 2 minus 2, again 0. Third is 3 minus 4 is minus 1. 4 minus 3 is 1. Then you have 5 minus 5 is 0. Then you have 6 minus 6 and 7 minus 7. So both are 0. Right? So these are DIs. Now compute DI square. 0, 0, 1, 1, 0, 0, 0. Right? This is what you have. So if you get this now, compute summation DI square. I from 1 to 7, here any 7. So it will be simply 1 plus 1, right? You have only two positive values here and here, rest are 0. So this will be simply 2. And now if you compute the correlation coefficient, what will this be? 1 minus 6 summation di square n into n square minus 1. This is simply the rank correlation. So this will be this 7 times 48. This will come out to be 336. 1 minus, and if you do this, I have already calculated it. This will come out to be 0.0357, or this is simply 0.964. So this is the rank correlation coefficient between the independent X values and the residual, right? This is the rank type. Now what you have to do, you have to use some softwares and all, compute the p-value. Compute the p-value, or you can also compute the t-statistic that I have defined previously. This is the t-statistic. Here, instead of RS, you can put the value of 2, basically. This will also do, and then you have to compare it with the critical value from the t table. Or the simpler way of doing this is that run this regression, find this rank correlation, and find the corresponding p-value. That if you use any software, it could be R, it could be Python, it could be Stata, any software will give you this p-value. This p-value will come out to be 0.00045. I will make separate video on how to execute this in Python and R and Stata later on, right? So as of now, just understand the process. Understand the process, find out the rank correlation coefficient and the corresponding p-value that will be given to you in the table itself, in the regression table itself, right? So this is the p-value that you have. Now, what will be the null hypothesis here? Null hypothesis is there is no correlation, there is no rank correlation between X and the residual term. That is, we consider homoscedasticity as we always do. In null hypothesis, we assume that homoscedasticity is present, which basically means there is no rank correlation between X and this. Versus in the alternative hypothesis, we assume there is a significant there is a significant correlation between X and this, which means heteroscedasticity is present, right? Now, this p-value that you have computed previously, this p-value will help you to make the decisions. What is the thumb rule? If p-value is less than alpha, that is the significance level, then you have to reject it. And that is the thumb rule that we will use in interpretation. So what we can say, interpretation, we can say clearly that the p-value, which is 0.00045, is strictly less than alpha, which is 0.05, which is alpha. Alpha is the significance level, right? P-value is less than alpha, which basically means that we must reject H naught. If we reject H naught, this suggests that, let me go to the next page. This suggests that a strong positive correlation between X and the residual is present, indicating heteroscedasticity. Indicating heteroscedasticity in the residual, right? Heteroscedasticity is present in our model, and the strong positive correlation what we found in our model will, indicate this decision, right? So, which basically means that the variance of residuals is not constant. So this is the entire thing. I hope this explanation is, sufficient and you got the entire process. Let me repeat whatever I have done in this video and then I'll end this video. So we started with the formal test. We have said that there are 3 formal tests in order to detect heteroscedasticity in any regression model. And here in this video, I have talked about the first test, which is Spearman's rank correlation test, in which firstly I have given you the formula in which you can find out this Spearman's rank correlation. This is the formula of RS. And then what are the steps? Here you have 3 basic steps. First is fit the regression model, find out the residual error. Then second step, ignore the residual and find out the ranks of the independent variable as well as the absolute value of the residual. The third step is to either compute T statistic and find out the critical value, and compare the critical value and the computed value, or you can use the formula of p-value. P-value has a thumb rule. If p-value is less than the significance level, which is generally taken to be 0.055%, then you will say that my null hypothesis is rejected and alternative hypothesis is accepted. Here, null hypothesis is defined as this: homoscedasticity, which means X and this has no correlation. This means X and this has no correlation. So if you remember what we have done in the residual plot is an informal way of detecting heteroscedasticity. Remember, I have told you in some video that residual plot is an informal way. So if you have a funnel shaped diagram, if you get the residual plot to be a funnel shaped plot, right? Funnel shaped plot in the previous video or the video before that, I have explained this thing to you, diagrammatically, that if you have a funnel shaped diagram, residual plot, then you will say that yes, heteroscedasticity is present, which basically means that as you change your value of X, your epsilon value will also change. So there is a strong positive correlation which indicates heteroscedasticity. But if the diagram is something like this, that this indicates epsilon, if this is 0, But if your values are residuals are evenly distributed in both the halves and you are not getting any correlation, then you will say that homoscedasticity is present. If you haven't watched that video, please check the video. Probably it is the consequence video. Please follow the playlist. You will get this video where I have diagrammatically also explained that how do you detect heteroscedasticity using residual plot. This is the same thing, but we are doing it in the route of hypothesis testing and inferential statistics basically. And residual plot is an informal way of detecting heteroscedasticity where if you have funnel shape, either it is like this or it can be like this, right? Either you are having funnel shifting or this, or it can be in this fashion also, like this. This could be another funnel shaped residual plot. So if you have either funnel shaped in this fashion or in this fashion, whatever be the fashion, you will say that yes, heteroscedasticity is present because X and the residual are strongly correlated. They have strong correlation, positive, strong positive, or strong negative correlation. That is why heteroscedasticity is present. But here in this type of a diagram, what you see is that there is no strong positive correlation. If X is increased or X is decreased, there it doesn't matter. Epsilon are independent of X values. So residuals are not varying with the X values, which basically means homoscedasticity is present. Or you can, take the help of this decision rule to do that. And then I have given you this example how to rank. Rank means simply giving the number. If this is the smallest value, give the number as 1. If this is the second smallest value, give the rank as 2. In this way, you are giving the rank of the values and rank of or the absolute value of residuals as well. And if you take the difference, that will give you the DI. Take the square of that, summation DI square, compute the Spearman's rank correlation. This is the formula. I have just applied the formula. You got the thing. And then find out the corresponding p value that will help you to land up to the result. Right? I hope this video is helpful to you. If you have any questions, any doubts, you can let me know. And if you like this video, do subscribe to my channel A in Economist. And I'll keep on making this useful videos for you. And stay tuned for the next video where I'll be going into the gold-field quantist, which is the most important and most popularly used method of detecting heteroscedasticity. So our next video will be on gold-field quantist. So thank you so much for your time.